Hi, guys. Thanks for joining. This is Essence of Science. Today, we're going to be talking about water in our houses. I'm Amanda Armagost.
Misha.
And I'm Dr. Abbasi for Essence. Now, water. Misha, that's a question, sciencey question, nerdy sciencey question for you. What's water?
Water, H2O, 2 hydrogen, 1 oxygen, and it's a
Correct.
liquid.
Correct. Now, while it is liquid in certain temperature
And certain pressure.
and certain pressure, that's right. And let's since it's the essence of science, you want to explain that, what that really means?
So when the temperature is high, water, like maintaining a same pressure level, when the temperature goes higher, the water is more likely to become vaporized into a gas. When the temperature is lower, it's more likely to become solid, like ice. And as for pressure, I forgot. Like
Okay,
high.
so I can make the water boil at room temperature
Yeah.
by reducing the pressure. As a matter of fact, if you reduce the pressure enough, ice goes from solid to gas directly. It doesn't have a phase, we call that phase of matter. There are three phases of matter everybody knows. What are the three kind of water you know, Amanda? In your house, you have three kind of water.
I have tap water, and I have
Is liquid, which is liquid,
Oh, I have water in the air.
which is the moisture or humidity in your house.
And I don't know the other one.
You do know the other one.
Ice cubes.
Yes, you have ice cubes in your
I
house.
actually want to do an experiment. I'm going to tell Charlie to bring me something. I want to do an experiment about hot and cold water.
Okay, yeah, you do that. But so, since this is the essence of science, we are going to be nerdy, Misha. What other state of matter are they before without gas, solid, liquid? What are other state of matter?
Plasma.
Plasma. What's plasma?
It's when something's hyper, like fire.
There's a definition, better definition. If you take a molecule and knock out all its electrons, then nucleus without anything else, without any electron, becomes plasma. Why is it important? Because it's so radical. Have you heard of the word plasma cutter? Where they cut a 2-inch piece of metal, iron, steel with a plasma cutter like it's butter. It just cuts through it. Have you heard of it?
Yeah, I've heard of it. Do you use it in surgery?
No, I don't.
Do
But I
people
have one in my garage. I have a plasma cutter in my garage, which use the electricity and an air pump. It send the air into that chamber. The electricity heats up and make the air molecules to a plasma, and that plasma like jets out of the nozzle, and that you can cut literally the thick piece of metal with that like a butter. It cuts everything like a butter because wherever that goes, it react with this local material and oxidize them and take the electrons away. That oxidation is taking electron away, and then it sort of cuts matter. So there are few other phase of matter. Since we are talking about phase of matter, I think it's important to know there are some other exotic phase of matter. What do I mean by exotic?
like doesn't exist in normal conditions? Does it has anything to do with Boltzmann?
That's everything. Everything in the universe has something to do with Boltzmann.
Like the
Everything.
state of the matter specifically.
The state of no, you say Boltzmann. Boltzmann. Are you talking about the Boltzmann demon? Are you talking about Boltzmann theorem? What are you exactly referring
No,
to?
like the name of the state of the matter. I know there's
No.
a fifth one.
Oh, there is another one called not Boltzmann. It's called Bose-Einstein condensate.
Oh yeah.
So let's talk about that. So we have at -5, water is solid in room temperature, right?
-5
In the
Celsius.
-5.
Let's talk in Fahrenheit.
No, we're not using freedom units.
No, this is the
That's a science-
US. Let's talk in Fahrenheit.
Okay,
for US.
-5 is like, I would say 23 degree. At 20 degree Fahrenheit and -5 Celsius, water in a regular pressure is solid. Between 32 and what, 200 something, 20 something Fahrenheit, or 0 Celsius and 100 Celsius, for God's sake, so easy. 0, it freezes. 100, it boils. Okay, so in that frame is liquid. After that, it become a gas. And if you increase the temperature of the same fluid to like 2,500 to 4,000 degree, it becomes plasma. Now, what is if it becomes much colder or much hotter? What happens then?
It evaporates.
Oh, it evaporated long time ago, Amanda. It evaporated already at 220 Fahrenheit. We are talking about 2,000 Celsius, or 4,000 Celsius, like 8,000 Fahrenheit. It's already plasma. What if it becomes much hotter or much colder?
I assume it explodes.
What do you mean by that? What is the explosion? Where's the explosion come from?
It just bursts.
No, it just, yeah, it's too hot.
You can't
Okay.
handle it.
At certain point, when you get to very, very high temperature, you remember in the plasma, the electrons are knocked out of the atom. Atom is a singular atom. Obviously, at that temperature, no bonds exist. The water is not water anymore. The water is hydrogen and oxygen. Because the energy is too far, too much, they wiggle too much. Literally, that's what temperature is. How fast molecules are moving. At that temperature, the molecule of the atom of the hydrogen and oxygen, they're moving too fast to stay connected. But then you get to a point that actually the nucleus of the atom falls apart.
I want to show you guys an experiment actually about the structure of water.
Okay, go ahead.
Okay, so I have to do it now because I just received these. I'm going to put the microphone by these. So actually the human ear can hear the difference between extremely hot and extremely cold water. So I'm going to pour these and I want you guys to tell me which one is hot and which one is cold. Ready?
Okay.
I don't hear anything.
You don't hear anything?
No.
Oh, Misha, did you hear?
Yeah, I can
ready?
hear it.
It doesn't come out through the microphone.
Yeah,
to
but
the...
I would guess the first one is hot.
No,
No,
the first one was cold.
first one's cold. I feel that the first one sounds lighter and crispier.
That's why, yeah, I would have thought it was
Yeah.
cold. Yeah, that's what I thought too. I learned that on TikTok, that the way that the water structures are, like depending on the temperature, it sounds different to you. So cold water sounds more, like Misha said, lighter and crisper and sharper, where the warm water, it sounds more round and soft.
But why? Why? Let me explain to you why.
Yeah, yeah, exactly. Explain why.
So, what is the difference between cold and warm water?
Like the speed at which their molecules move, it's faster in hot water.
And that results in that they're easier turned into gas. A warm water, there's always a certain number of the molecule of the water that evaporates. Now, imagine if the water is warmer, more likelihood of the molecule from the surface of the water to evaporate go to the air. So there is always a higher amount of humidity just above the water of the warm water than the cold water.
Makes
So,
sense.
what does humidity does to the sound transfer?
It blurs it.
It dampens it.
That's a good one.
Yeah.
So here you have it. So without your experiment, just knowing the physics tells you what to expect. And that's what science is. Science is telling you what to expect when you do certain things. If you put this and this together, then you have this. Or if you throw it at certain angle with certain energy, you result in this. That is what science is. So nice science experiment, Amanda. So very hot, you don't have water anymore. Too cold, you have, especially if you have too cold with a lots of pressure, or if you have too much pressure, you have an exotic kind of water. You don't have it in your home, so we won't go deep into that. But that is the so-called the metallic water or metallic hydrogen. When you have a lots of pressure, you have a hydrogen or water that look like metal, behave like metal. You don't have it in your home.
There's a lot on Jupiter, right?
That is, as a matter of fact, there's a lot of that is on Jupiter. And
When
then,
you say it behaves like metal, what do you mean by that?
so what is the difference between a water and your hammer that you take in your hand? What is the identity? What makes it one to be a metal of your screwdriver versus water? Imagine literally in certain situation, the molecule of a hydrogen of that gas, they behave like a piece of metal. They conduct electricity. They are
Wow.
solid. You can, if you could in that environment, you could hammer and shape them and they keep their shape.
What about like they're not magnetic?
They can be magnetic, yes.
Really?
Yes, they is metallic hydrogen, certain that requires a lot of pressure. And even though in that temperature, it's very hot, it's not cold, but because of the temperature, you see, there's an equation that the volume, pressure, and temperature are related. You can change them to change the other properties. So in that temperature, it is hot as the core of the sun, but the pressure is so high that not only it contains that gas to become a solid, but it becomes a solid like a metal. Again, it's not in your home, so title of this podcast is the water in your home. So let's not be concerned about that. But just to complete the loop, there is a temperature things that is, I think, what you were referring to, Misha. It's called Bose-Einstein condensate. Have you heard of that?
Yes.
What
on
is
your
that?
podcast.
Oh, we did a podcast about that. So
No, we briefly touched on it, but we didn't really go into like what is it and how to create that phase.
okay. What about if I told you there is a temperature, if I decrease where you guys are, when two of you are sitting there, if I decrease the temperature in that room, all of you, including the table and the mouse and air in the room, including your sound, including your thought, become one single atom.
Did I do something wrong?
I know. I was like, I didn't
Did I do
realize
something wrong?
I annoyed you that much 2 minutes ago.
What?
Never tell him I'm human again.
Wow.
So there is a temperature when matter behave in certain ways, okay? Like when you're pouring liquid, you're pouring water, the molecules slide over each other, and then you can separate the molecule from the other. You can make from half of the water acid, from the other half, you can make a caustic other solution. You can cook with the half of it, you can do something else. But there is a temperature when we decrease the temperature of helium, all the molecule of the helium, they behave the same way as if they were only one single molecule there. Like it loses the friction, it loses the characteristic that makes it different, being made of different molecule. We have made that is like a zero followed by 9 0 and then a 3 degree above the absolute zero. And that temperature, that the coldest temperature, by the way, we have observed or seen or made in the universe. The coldest temperature. In that temperature, the molecule of the helium atom, and they could reduce that, like, the 1,000 or few thousand atom of helium they could bring to that temperature. A very fancy experiment. But then you don't have 1,000 atom of helium. You have 1,000 atom of helium that they behave the same way. They become one. So again, that's not in your house, at least not that we know, Amanda. So
What
let's
is
not
in
talk
the
about.
house?
Huh?
So let's talk about what's in the house.
In the house, you have three phases of water: solid, gas, and liquid. Now, to understand how that water behaves, you have to talk about what is, Misha, what is the universe is made of?
Atoms and
Mm,
electrons.
Energy,
as well, atoms, energy,
stardust.
Void.
void, lots of void.
Void.
Is there a real void though?
The Boyd's void.
The void has an energy level. That's one of the things that Einstein called it his hugest blunder, that his calculation wouldn't work until he would put a constant on the vacuum to compensate for that.
Dark
And
matter.
Einstein's hugest blunder become his hugest triumph, because now we know vacuum void has a very low energy, but it's not empty. Space is not empty. Space itself has an energy volume. As a matter of fact, everything you see in the universe is only 5% of the universe. From that 5% of the universe, the matter, that visible matter you see in the universe, most of that is energy, and a small fraction is atoms. What are those atoms mostly made of? What are those atoms?
Quarks. Protons and neutrons.
Well, let's put it this way. I'm going to choose my words very carefully. From the matter in the universe, 80% is hydrogen, 20% is helium.
Is the answer you're looking for elements?
Well,
Gas?
don't you think this is odd what I just said? From the matter we see in the universe, everything we see in the universe, including you and I, statistically, 80% is helium. I'm sorry, 80% is hydrogen, one proton with one electron, two of them come together to H2, and 20% is helium. That is how universe started after Big Bang. 80% hydrogen, 20% helium.
Yeah,
Well,
you got to start somewhere.
No, but what is odd about that? What is odd about that?
Like, why would some protons double up to become helium, and why would some remain
That
to be?
was the Big Bang. That is what happened in the Big Bang. But 80% and 20% add up together to 100%, right?
Yeah.
What about the carbon in your wood you are sitting next to? What about the iron in that metal piece that you are having? What about all the molecule, calcium molecule make your body? How does it that 80% hydrogen and 20% helium is make the entire universe? So what about all the other things?
I would feel they combined, like more protons creating new elements.
No,
Like
but what I'm getting at is that everything else is statistically irrelevant. Like all the calcium in your bones, all the carbon in your body, in your proteins, the metal in front of you. We have a lots of it. But statistically, if you look at the universe, all of that is irrelevant. The universe is made of hydrogen, and literally you have to put too many zeros to find out all the other elements. That's what the universe is made of, hydrogen and helium. Now, obviously, water is not made of hydrogen and helium. It's made of hydrogen and oxygen, right? By the way, what is the atomic weight of hydrogen?
1.
Why? Why is atomic weight of hydrogen is 1?
Because it has one atom.
No, yes, in a way, yes. We just made it up, man. We
Oh.
made it up. We just made, when the old chemists start measuring the weight of certain elements, they see how they combine. They just assigned 1 to hydrogen, and they measured everything else against hydrogen. And when they measured helium against hydrogen, what did they find out?
It's 2.
Actually, it's 4.
It's 4.
I thought carbon was 4.
Carbon's
But-
6.
Okay, no, it's
Well-
sweet. It's
8.
sweet. Okay, that is exactly why we are doing this. You see,
Done chemistry since high school.
I really enjoyed my chemistry in high school. I had the best chemistry teacher, Mr. Dale.
okay, so here it is, the periodic table. Are you able to see that?
Yes.
Okay, helium is 1. The reason helium is 1 because we decided we are going to measure everything against helium. That is why atomic weight of helium is 1. That's it. We didn't really had a 1.
No, you mean
Yes.
hydrogen.
Huh?
You mean
Hydrogen is 1, helium is 3.
I'm sorry. Here,
Helium
hydrogen.
is 2.
It's 2. Isn't that what you
Helium is
said in the
2?
first place?
Yeah, that's what.
Wow, that's what Misha said, and you said no.
But listen to me now. Hydrogen is 1. Helium, actually, we measured. Do you see that 4 there in the corner?
Yep.
Now, we didn't talk about the periodic number. We talked about the atomic weight of helium, right?
Oh yeah, you're right.
Let me see carbon.
No, but let's stop here. Don't go too fast here. Helium, hydrogen is 1 and 1. Helium is 2 and 4. Not exactly, but almost.
Because it has neutrons, right?
Here you are. The
Oh.
atomic weight is not the number of the proton, but as well the neutron in that. So when they measured hydrogen against helium, helium had 4 times the weight of hydrogen. But when they measured, like, let's go like oxygen. Let's look for oxygen here. Remember we talked about the atomic weight of oxygen?
Yes.
It's 16. But it has only the periodic table of it is 8. What that means,
It has
What?
8 protons.
1 part of hydrogen can in ways react with, no, 1 part of oxygen can react with 8 part of hydrogen in ways. But when you measure them, for 1 part of hydrogen is 1/16 weight of oxygen. So meaning that 8 proton and 8 neutron makes 16. Okay? So we are not going to talk about periodic table. We are going to talk about the water. So universe started with Big Bang. Big Bang created 80% hydrogen, 20% helium. Nothing else is there. Well, some trace element of other things are there, but they're so rare you can neglect them. But then lots of this hydrogen, they come together under weight of themselves, they compress, they become a star. And they start turning hydrogen in helium. Toward end of its lives, it burns helium to carbon from 2 to actually atomic weight is anything else, but mostly carbon. That's how the reaction works, okay? But then it burns more and more and create all these elements all the way up to iron. At that point, going from anything else to iron requires more energy. So in the core of the star, the pressure and the temperature collides the atom together, make bigger and bigger atoms, and the energy released from that push outside, keep the star in equilibrium. Once they get to iron, actually from here to here, it absorbs the energy, so a star collapse and explode. What's called when a star explodes?
Supernova.
Supernova and hypernova. It's a small distinction between them. Now, anything else after that is produced in a so-called hypernova to a certain point, and then it's a different mechanism, neutron capture, but forget about that. Now we have hydrogen and oxygen. They make water for us, correct?
Water in your homes.
And that makes the water in your home. So what is special about this combination, hydrogen and oxygen? Why is it, I mean, life is made of water, right? Any life form we know is based on water. There are certain characteristics, and the reason you have water in your home, Amanda, is because without that you would die.
Yeah,
If you don't drink water, how long can you live?
like 3 days.
Yeah, if you don't you don't take the water away, about few days is all you can. There's a rule. They say a month without food, a week without water, and a few minutes without air, right? So that water, this combination of hydrogen and oxygen had certain characteristics that makes life possible. Do you guys know what those characteristics are that makes the life possible based on water?
I can't say I do.
Does it have anything to do with carbon?
Well,
I remember in chemistry, like we were always hearing that carbon, everything is made out of carbon.
Carbon-based life.
Yeah.
yeah, so see, there is so-called water-based life. That's everything we know. There's some theories that maybe there is a not water-based life. So when you see fluid, liquid water in every planet, then scientists get excited. Oh, it might be water there. And then there is a carbon-based life, and there is good theories that there are silicon-based life as well exist. But again, that is a life. Let's talk about water. Why is the life as we know it based on water?
We all need water.
Why? Why though?
We're made out of water, like 80%.
Why are we made of water?
It
Yeah.
circulates pretty well.
Okay, well, let's put it this way. We are a bag of chemistry. Our body, life is a chemistry lab. A chemistry lab, have you ever done chemistry lab? You said you loved it.
No, I loved the class.
You loved the class. So chemistry happens in solutions. You cannot just bring two molecules together. You have to mix them. And you have to mix them very, very closely. For that, you need a solvent. And that solvent happened to be for life water. There are other solvents that are not water-based, but the good beauty of water is, number one, is plenty of it out there. Number two, it has a polarity. Water molecule itself has a polarity. What do I mean by that, Misha? When I say water molecule has a polarity?
I guess polar bonds.
No, the water is made of hydrogen, two hydrogen, and one oxygen, right? Let me share this with you here. Water molecule. So here it is. Do you see it now?
Yes.
Oxygen is 16. Hydrogen is 1. And oxygen has a lot of nucleus that are positive. They take the negative electron from the hydrogen more toward itself. That means hydrogen has less of an electron. It's an electron they share. That's what the covalent bond is. but that electron is more toward the oxygen than toward hydrogen. What that means, the water molecule has a negative side and a positive side. And I cannot emphasize to you how important it is. Without that, there would be no life. Without that, there would be no water as we know it. Without that, no chemistry on the planet would exist or function. This polarity of water, what makes it the whole chemistry possible. Now, sometimes a long time ago, it was a mud with lots of water in lots of molecules. They could move freely in this water. Because of the polarity of water, this molecule could literally surround themselves with water and then interact with each other. And that's how life came to be. But there is another capacity of the water that makes the life possible. Imagine you have ice. What happened to the ice? Is it lighter? Is it floats or does it sink?
It floats. It's lighter
Why?
because
It's less dense.
It is less dense, exactly. That would be the only reason anything would float on water or any fluid if it's lighter, okay? Now, but why is, we know when something gets cold,
and
it actually, if anything gets cold, like a piece of metal, anything gets colder, it gets smaller because molecules come closer together. Why is ice crystal less dense than water? Because everything else in the whole universe, when it gets colder, it comes together more and it becomes more dense, not less dense. Why?
I don't know.
I just know that it gets bigger when
Yeah,
it gets cold.
kind of
So
intuitive, right?
yeah,
When
it's
it
the opposite.
freezes, it's opposite.
So I guess maybe like the structures are further apart and that helps it to be bigger and float.
The world is fake.
Now, do you remember what we talked about, the polarity of water molecule?
Yes.
So what that means, at beginning, all these molecules are everywhere. They're floating, they're interacting, they're going back and forth. You make them colder, they are now moving less and less. They are moving less and less until at certain point, the polarity of water causes, oh, that's not the regular ice. I'm going to look for a regular ice molecule.
It's okay. You can totally fool us. We don't know what ice molecule looks like.
I hope after this you do.
Oh yeah, definitely.
Actually,
I know I will.
okay.
Are you gonna look in your ice cube and then go, oh,
I'm gonna look at my ice cubes very differently.
No, you only see ice one. There is no way you can see any other ice. But imagine now that this molecule now that you are slower and slower, they have a positive and a negative side. They are polar. They sort themselves in a lattice, in a crystal structure. That crystal structure have more empty space between than if you would let them float freely. What is the densest statue or situation for water? At what temperature water is the densest?
4 degrees Celsius.
Good one, very good. What does that mean? In the coldest place of the ocean, is water is 4 degrees on the bottom. 4 degrees on the bottom. That's the coldest place the bottom of the ocean can be. 4 degrees because that is the lightest, that's the heaviest water, correct?
Yes.
Now imagine if the ice was colder than 4 degree water, if ice wasn't floating, what would happen? Amanda, you live in Minnesota, we have 10,000 lakes, right?
Yeah,
What happens in winter to water?
the ice freezes.
All the lakes freeze, correct?
Yeah.
But underneath, when the ice,
Well, it doesn't freeze all the way to the bottom.
Why not? Why doesn't it freeze all the way to the bottom? Is it not cold
I'm
enough?
pretty no, I think it's because there's plants down there and they like photosynthesize and make it a little bit warmer.
No, no. Misha, why doesn't it freeze all the way down to the bottom of the lakes in Minnesota?
Like I think it's just not cold enough
Oh, I know. Actually,
because water like holds a lot of heat, right?
You
And
guys
it
are killing me.
the ice
Come on.
it insulates the top part
Yes,
is insulated
yes.
and the
The
bottom.
ice is the best insulator. So lakes freeze in spring, it thaws, all the fish are still alive because it freezes a foot or two, but after that, the ice itself insulates the rest of the water against the cold, so it doesn't freeze anymore. Okay? Now imagine the ice that would freeze would sink to the bottom of the lake. If the lake would freeze from bottom up,
You have no fish.
Wouldn't it just become like a cycle?
no, the life would, yeah, okay. In end of summer, there are lots of fish in the lakes. It freezes over. Next spring, there's still a lot of life in the water.
Mm-hmm.
Now imagine the water would freeze from bottom up instead of top to bottom. If the ice was denser than water, what would happen? The lake would solidly freeze from bottom up.
Then you can catch fish walking on the lake.
Well, I would assume actually that if that was how life was, then the fish would have adapted because there's certain things like frogs. You can freeze a frog and it can come back to life. Same with a turtle, same with an alligator. So
I give you that. But life is based on the life as we know it is based on ice freezing top to bottom and not bottom to top. So now water in your house. Did I just tell you that water when it freezes, it's lighter? What does it mean? It's less dense. It means it expands.
That
Mhm.
means your pipe might explode.
That's
in
why,
winter.
yep, that's why in the winter, if you live in Minnesota, you need to open up your sprinklers.
And empty the water from it because
Yep.
water at 4 degrees the densest. After that, it expands, meaning the ice has need more space than the water. So if your water pipe outside, if they are not expandable, like they are not plastic, even if they are plastic, still they can damage it and explode. But one of the nice the experiment is they put in a metal, huge, thick metal. They fill it with water and they freeze it. And the thick metal, it explodes when the water freezes inside of a metal container. And that metal container, I'm talking about 2-inch thick now metal. Can you imagine just freezing water inside of a 2-inch thick metal would explode or practically break the metal? That is how strong it is when it's built the lattice. That is the molecular structure, how big it is. Now, we talk about, again, water in your house, Amanda. That water in your house, it comes as well in a vapor. And that is what you feel as a humidity in your house. And how much humidity do you need to
Well,
really?
we do need a certain amount of humidity because if you don't have enough humidity, then your skin gets dry, your nose gets dry, and your throat. I don't know what percent you need. Maybe
50?
I feel like 50% humidity might be. I feel like that's close to. I would say maybe you need like 15 to 18.
Mhm.
Yes,
Yeah,
it's-
you wanna look it up, but let's talk about what happened if you had let's say in a magical place you had 0% humidity of the room in your house. Now you're talking about your skin and so on. I'm concerned about your cornea, your eyes. I'm concerned about your lung. I'm concerned about all your mucosa would fall apart. I'm concerned about you would be losing so much water through your body, that you would literally die. So what does the computer say about what humidity level is comfortable for human?
30 to 50.
That is what, but you know what that means, though. That doesn't mean that half of the molecule in the air are water. What does that mean? What does it mean? 50%. Let's put it this way. What does it mean? 100% humidity. What does that mean?
Yeah, I would say that means that it's going to be rainy. Like there's going to be
Very
water.
good. Perspiration. That means that if you add more humidity to the air, just by a random fact, that molecule come together, become liquid again, and you have rain. Okay? So obviously, this is not a linear thing. And this is depending on the temperature and pressure. Okay? So this is 50% humidity on Mount Everest is not the same like 50% humidity on the ground. Okay? So, but what that means is that in your house, the practically you need 30 to 50% humidity to feel comfortable, meaning that you are not losing too much water. Why isn't 75% or 100% better than 50%? If water is good for you, why 75% is not better for you?
You
Then
don't want too much water, like
why
mold.
not? Why not?
Well, we have the answer right in front of us, but excessive humidity can promote the growth of mold, mildew, and dust mites, and it can trigger allergies.
Yes, but as well, you won't be comfortable. Why not?
It'll be humid.
Yeah, everything will be.
It'll be wet and
slippery,
sticky. Yeah.
Okay, but what is wrong with being wet and sticky?
It's not comfortable.
But
What's the answer you're looking for?
the answer I'm looking for is human body regulates its own temperature, but evaporating fluid from your skin. If
So you
the
would be
humidity is
sweaty.
too high, you cannot get rid of the temperature of your body by using sweating to regulate your body temperature.
Even if it's like 20 to like, can you have a super high humidity and it be really cold?
If it's super high humidity and it's really cold, then the fluid becomes the air, the molecule of the water in the air become liquid, and you have precipitation. You remember I said that those humidity has something to do with the temperature and the pressure?
Yeah.
Okay. Too low of a humidity, you lose too much air, your mucosa become dry, you can literally die by dehydration. Too much humidity, you cannot get rid of the temperature by evaporating your sweat. That is what the sticky means. That is why uncomfortable when you go in a very humid place. That's why you're uncomfortable, because you cannot regulate your body temperature. Okay. And that is not, see, I think you guys got frustrated because you were going circular. It is uncomfortable because it's humid. It's humid, and that it's because uncomfortable. And so
What
on.
about steam sauna?
No, well, yeah, let's talk about steam sauna, because that might be in my house. I have a steam sauna. That is part of the water in my house. What are you doing with that? With the steam sauna? What are you doing?
You're trying to sweat.
You're sweating, but you don't stop sweating, because you sweat, it evaporates, and then you stop sweating because you cooled yourself down. Now you are in steam sauna, you sweat, but because of the humidity, the sweat doesn't really cool you down. Then your body knows only one way to sweat, to cool you down, to sweat more and more and more. Yes, then you're sweating more and more and more. Now, obviously, you don't do it for unreasonable amount of time, because that's unhealthy. But why? Steam sauna can be very healthy for you.
People want to get rid of their toxins, and they feel like if you're sweating, then it can help release some toxins.
Okay, Misha, what do you think?
I feel the steam sauna helps me sleep.
Yeah, no, it has lots of effect, but one of the effect is that literally why do you go to gym? Why do you go to gym and start lifting weights and so on?
Because it's good for mental health.
I think you're looking for cardio. Is that the answer you're looking for? You want
not
someone's
a
heart
gym.
rate,
Well,
heart rate
you go
raised?
to gym, you bring your system to the border what it can do,
Yeah.
and then it can do more. Every time you bring a biologic entity to the border of what it can do, your body, your biology knows, I have to do this. Let's prepare for a little more. Like you start lifting, like Amanda, you go and start lifting 5 pounds. Your body says, I have to be prepared for 10 pounds. Then when you do 10 pounds, it gets prepared for 15 and so on. That is what workout and gym is. Look at you goofy people.
What?
So that is why you go to gym. You go to gym to put your body at the border of what it can do, so it can do that and maybe even more. Sauna, that's what it is. It put your body at the border of what it can do, so your biology, your homeostasis is prepared to do more. Same by jumping in the ice water or taking cold shower. Same going to marathon or doing anything activity. Same like when you literally increase amount of the pressure you put on your bone becomes stronger.
So I have a follow-up question. So what's the difference between dry sauna and a steam sauna?
Okay. Either sauna works with make you sweat, put your body as a stress situation, and the sweat is not reducing your temperature. Now, in a dry sauna, it's just the heat and the temperature that prevent you to lose heat. In steam sauna, it is the inability of your sweat to evaporate that prevent you to lose your temperature, and you stay hot, and your body goes on overrun. You literally go on overrun. Okay. Additionally, in a steam sauna, because of high humidity, all that humidity really opens up your airways. Internally, you're secreting a lot of fluid in your nose, in your lung, to keep it moist. It's just a race against, can you produce enough fluid there to keep those temperature, to keep a layer of fluid. Your lung is like a tennis court of surface. Can you imagine that right now? Every time you breathe in and out, the air gets exchanged in a surface that is the size of a tennis court. Now, the only way air can get exchanged is exchanging against the fluid. So there is a membrane, small membrane of fluid in entire your lung, few molecules thick, but without that molecules, you will suffocate and die. Now, and your body is always doing that. Now, when there's so much humidity in the air, your body opened all the airways, opened all the ways, and stop creating any more fluid there. And that as well help your airways or your nose and so on. If you go ever to a steam sauna, you notice your nose become very open and you can breathe through them much easier and so on. Have you noticed that?
Yeah.
Yeah, and that as well good for airways and so on. Now, obviously, just for a period of time, that's good. But beyond that, that can as well has its own, you can suffocate, drown if you're in a wet sauna too long. You can drown in your fluid in your lung. Okay, so everything in moderation. So, what other kind of water do we have in our home?
Do you mean like tap water, like water from the shower?
Yeah, well, we have water that without the shower and so on, tap water and so on.
We
Now,
have gray water.
okay, let's talk about tap water, then gray water, and then we stop here because I think you guys are just had enough of science. So,
Okay.
tap water, what is it? What make the water taste good or bad, Amanda? What do you have good experience with that? What is but
So
makes the
tap water is the city water. It's the water that the city purifies at whatever level they feel necessary. Most areas have less than what humans really enjoy drinking. So there's a lot of different minerals and chlorine and things in the water, but you can have like a reverse osmosis system, which is what I have at home, or different filtration systems.
What is the so-called distilled water? What is that?
Is when you boil water and turn them into vapor and then condense them.
What is special about it
There's nothing in it except for water.
except for water? Do you know how it tastes?
Like nothing.
Very smooth.
There was a time I addicted to distilled water.
Okay, it tastes horrible actually.
Okay, that's
It
an
tastes
opinion.
it tastes
Actually,
all right.
actually, that's an opinion.
Oh,
I used to be addicted to that.
Yeah, I like distilled water, and actually, we were in Florida, and you just bought a gallon of distilled water.
okay, well, generally, by average people, the distilled water taste is considered not good. That is what the studies say. I didn't make it up. Look it up, okay? Just look it up. And the reason for that is life likes what's good for it. Life dislikes what's not good for it. Can you understand that?
But isn't like you love reverse osmosis water and you don't drink tap water?
That is not
But-
the distilled water. No, we
Yeah,
will
but
talk about
it's
reverse
the
osmosis water.
argument. It's the same argument. You
Yeah.
told me not to feed my pets reverse osmosis water because they need the minerals in the tap water.
Calcium. Yeah, okay. The reverse osmosis, I think we are mixing two different things here, okay?
No, I understand the difference. I totally 1000% understand the difference between distilled and reverse osmosis. I'm saying that your argument that humans prefer tap over distilled because we need it for our life isn't very a fluid argument, because you prefer reverse osmosis over tap, and we have stuff in our tap water that we need.
Okay, so tap water had too much calcium for you. Too much calcium for you makes your artery calcify, make kidney stone, make bladder stone, make lots of other problem. That is why hard water, we call it, it tastes bad to us because it's bad for us. Because over 80 years of life, after just half of it, your arteries are clogged with calcium plaques. Too much calcium, not good for you.
So hard water isn't what comes in. I thought that hard water was what is going into your water softener. And then after it's your water softener, then it's normal water.
I wish that Kurosh would be here to listen to this. Okay, I'm not trying to diminish your understanding of that, Amanda. You are mixing 20 different things together though right now. And let me clarify it. If you let me explain to you, distilled water is only water. It doesn't taste good to the vast of the humanity except you, two of you, because the vast of the humanity, when they did those tests, what does it say, the internet, about the taste
It
of?
says it's some individuals may enjoy the purity and others may prefer water with mineral content.
Mhm.
It's all about taste, like what some people like.
Yeah,
and some
the
people
internet's
don't like.
pretty inclusive right now.
So, the distilled water is only water. The regular tap water has minerals and lots of other solvent in it. 9 out of 10 times it had too much calcium. That is what's referred to hard water. Now, reverse osmosis is a process to push the water through a membrane to remove mostly big molecule, calcium molecule from your water to reduce hardness of the water. And the hardness of water is measured about how a soap would react in the water. That's how it's measured. So, and the reverse osmosis removes almost 95% of the calcium and makes the water smoother without removing other stuff, other smaller molecules from the water. Now, the water softener is a different process. The water softener as well removes the calcium, but with a different process that is cheaper than reverse osmosis to remove that. Misha, do you know what is the process of what most of water softener do to remove the water from your calcium from your water?
Consume salt.
Yes, they do. Regular salt. But how do they how do we use salt to remove calcium from water?
I don't know, but I can guess they bound something, maybe sodium or chloride to the compound that contains calcium in the water, in hard water.
Amanda, do you have a water softener in your house?
Yeah.
There is a place that you put salt in it, correct?
Yeah.
And does that salt ever come in contact with your water in your pipe? Does your water taste salty?
No.
So that salt never comes in contact with your water that you consume in your house. Is that correct?
Yeah.
Now, how does that salt, though, help to remove calcium from your water in your pipe? Now, in a regular way, there is a resin. There is a specifically designed resin that when you run the water over it, it has an affinity for calcium. So you run the water over it. When the water goes in, it has, let's say, it has 1,000 calcium molecules. When it runs out, it has only 100 calcium molecules. That resin literally has bounding ligand, we call it. Ligands that the calcium binds to it, and it doesn't go out of the other end of the pipe. And that is that big, in every water softener, you have that big container. You have does your water softener has a container?
I think so.
Yeah, all of them have. That is where the resin is. But then you eventually that resin is saturated with calcium, meaning that there's no more ligand or places that calcium can get bound and be removed from the water. Now, salt come in the process of removing those calcium from those resin so it can regenerate. That's what it's called, regenerate. Now, sometimes at 2 a.m., probably in your house, Amanda, your water softener system stop the water flow to your house. That is why it's usually at 2 a.m., where people don't need to use the water. Then it literally cuts off water in and water out to your house. More refined system, they bypass it, or they have two systems. When one is regenerating, the other system is in use, so you never run out of water. But either way, it separates that container with the resin from the water circulation, and it puts a very, very salty brine into the resin container. Like, this is the ligand, this is the calcium here. Now it puts like 100 sodium atom there. That sodium atom itself is irrelevant, is really nothing, but if you have 100 of it, they push the calcium away. And now this is filled with sodium. And now you wash it away, you wash all the calcium away. That's why you hear your water softener literally washing that resin with brine, with the salty brine, remove the calcium from the resin and wash all those calcium away. That's why your water softener has a hose that goes to the drainage, to the gray water, to the sewage. Now, once the resin is filled with sodium, you rinse it once through. The sodium is still there, but the next time calcium comes, replace that sodium with calcium, and now it's regenerated and can again absorb the calcium. Too much, or does that make sense still?
Makes some sense. Yeah.
Some sense. Okay, good.
Yeah, I mean, as long as I know the water's not in direct contact with the salt, that's fine with me.
Yeah. So it is not, because that regeneration happens in certain time where the resin get washed with the brine and then washed away again. So then let's finish it up with the gray water. What do you mean? What do we mean with gray water?
Not drinkable water.
Toilet flushing.
It's used water that's been used throughout your house.
Yeah, sewage, your sewage. Okay. From everything, I'm just going to tell you one sentence regarding that. From everything in human history, the invention of sewage water and managing it had the most impact on health of humanity and growth in numbers of the population of the human race. Do you know what I mean by that, Amanda?
Yeah, but it's more sanitary. Now there's a separation between clean and unclean water. And then I think also a lot of times gray water can be filtered and reused in different ways. Like you don't use it for drinking and showering, but you use it for like flushing your toilet or use it for your plants and things like that.
Yes, and good explanation. But what I mean is literally historical, meaning that imagine certain point in time, humanity started, it goes up and up and up and up and up and up, a little more human, more human, more human, until we figured out how to manage our wastewater. Then humanity exploded. Because before that, there were more people, or almost same amount of people dying than being born, and people lived not that long. Once we started managing our gray water or sewage, humanity start exploding. These are not unrelated. Every study shows that the reason humanity start growing is not our knowledge, is not medicine, is not vaccination, is not lack of water or anything. More than anything else, the management of the gray water was the most influential thing in humanity to grow. Okay, I think we did enough of the water in your house and science related to that.
Yeah.
Okay,
Thank you
Really
guys for
informative.
watching. This was Essence of Science. We talked about the water in our house. Next, we'll talk about soon different types of water in the house again.
Okay.
I'm Amanda Armagast.
Sure.
I'm Dr. Abbasi for Essence. Thank you.
Thanks, guys.